All right, I think we're live again. Hey, everybody. Welcome to another Nourishing Greatness with me, Jim Christian with the DMO. And of course, I have my compatriot, Joe Seclitz, also from the DMO. And we got a special guest on today. We got Scott Stouffer from Market Brew. Scott's been a fan of the DMO and Advanced Search Summit for a long time. We've known him for quite a few years, and he thought that this would be a great time to let all of you know about our Lunch and Learn by introducing us to creating your own GoogleBot. So Scott, why don't you do a quick intro for everyone?
Sure. So I've been doing this for about 20 years. I've been doing software mostly. My background, I would say, is probably not what you consider the conventional SEO background. It's more of sort of a story of a software engineer arriving at the SEO space and sort of finding his way through building a search engine from the ground up, sort of in parallel with with Google over the years. And so that's sort of what I've been doing for the last, seems like forever now. I think our current business, where we build search engine models for customers and other software projects for people, for about 15 years now. So that's sort of what I've been doing. You can ask away. Any other questions? Sweet.
Well, I just want to say that I'm probably freaking some people out because I'm in Newport Beach right now, and supposedly in the background, look, I can do this.
Yeah, turn down your brightness. There you go.
It's the ocean, baby. Yeah.
That's nice.
So, and I have a ton of lights on me right now, which is crazy too. But yeah, I mean, I think Joe and I were both interested in knowing how to create your own Googlebot and try to, learn, I guess, from an insider's perspective of like how Googlebot works and what people can kind of assume when a bot comes and crawls their site. So happy to have you on. So let's get into it. Oh, and I should say real quick, if anyone has any questions, please feel free to put them in the comments below for YouTube. We'll see them live and we'll field them over to Scott. So please ask away. All right, take it away, Scott.
Sure. Okay. So I want to approach this as agnostic to the technology as possible. So what I mean by that is a lot of people are getting excited about coding in Python. That's the if you follow Hamlet, great guy who's really pushing coding in Python. And of course, that's a very common programming language. The search engine that we built at Market Brew, the first one, was actually written in Java, and so it's a sort of a large scale, enterprise scale software. So it's not the same approach, but it's sort of the same fundamentals, the first principles of building this. So today, what we'll do is we'll just kind of focus on talking about how you build the first component. I would say the first layer that touches a client's or somebody's website, and that is the crawler. So there's sort of a different way to break this up, but the way that we broke it up is, first you have to crawl a site, then you have to properly store that data and index all that data. The next thing you need to do is build a scoring layer. So it has to have some sort of similar scoring methodology and algorithms to the modern search engines today. And then the query layer, which is interacting in real time with the user as they type in the search results. So those are the four sort of layers in a modern search engine. And we'll go deep into sort of like today's talk. We'll be talking about just the crawler part of it. But if you guys want to talk about other things outside of that, or if you have a question about something that's outside of this scope today, I'm happy to answer it. But I just wanted to put that in context today, is just talking about if you're somebody who's interested in building a crawler, and this is going to be somebody who's probably a software background or somebody who's interested in software enough to start fooling around with creating something like this. I highly recommend it, just as an experience to understand how the Google engineers started and went through and discovered all the sort of what I call the long tail of the internet, essentially, which is you'll find out that it's sort of like the Pareto principle. 80%, or I'm sorry, 20% of the sites out there are going to give you 80% of the problems, or other way around and you want to look at it. But essentially, this is going to talk about the things that I wish I would have known when I started building a search engine. Obviously, I had a little bit of a head start from my software background. I used to build large-scale systems out in Palo Alto at the time that Google was actually building Google back in the late 1990s. And so I have the software background, but I want to give a little bit more information as to the software perspective of things. I know a lot of you out there don't get the opportunity to talk to a Google engineer. Whether, that's obviously mostly due to restrictions from Google. They have NDAs. They have specific public speakers that will come out and talk about, the JavaScript compiler or whatever it happens to be. But it's very controlled, and it doesn't really allow all of you who are outside that Google bubble to understand exactly what really is happening inside of a modern search engine. So I'm trying to sort of put myself out there to answer any questions that have to do with that part of the process. So, all right. So should I start? Does that sound good?
Yeah, absolutely.
You want your slide deck?
I don't have a slide deck actually, and in fact, if you want to just point people over to askthesearchengineer.com, I set up a site called ask.thesearchengineer.com.
Bring it up.
Okay, yeah. So let me pull that up right here. Marketbrew.ai is a commercial product that we commercialized off of some of the stuff that we're talking about today, but that's a different story. We can talk about that later. Yeah, so Ask the Search Engineer, have a nice little Google engineer here on the top. This basically will kind of go through and talk about all of the different processes to building that search engine, and all the things that I learned. Again, I wish I would have known. So we'll go through and talk about how to build the web crawler today. The first thing I want to do you want me to just follow along on the page?
Sure.
Yeah. Let's see here. Let's move this over.
It was askthesearchengineer.com?
Ask.thesearchengineer.com. And I actually have a form there too as well. So if you guys think of a question after this call and you want to do it offline, you can always just fill out a form there and I'll be happy to just answer it. There's no strings attached. I'm just kind of giving back to the community with this site. All right, so let's talk about sort of how web crawlers began. Back in the day, you had a number of search engines that were mainly based off of just content, right? It wasn't link based. And Google, obviously, we all know the story. They came along and built this crawler called Backrub. There's a whole story on this. We can talk literally for a whole week on this specific topic. But what really happened was over the last 10 years, over the last 15 years, let's say 20 years, the Google team has kind of gone through this process of going from a rules-based engine and learning all of the long tail of the internet. And what you see today with Google is sort of like the machine learning-based, AI-based version of that, with the rules-based engine sort of still inside of it. But essentially, what the first thing you're going to be doing is sort of understanding what's the limit of crawling, right? So if you're going to start out and say, I want to build a crawler, the first thing that you're going to want to ask is how in the world, what content should I crawl, right? So the first things that you have to do when crawling a URL is to identify what type of content that you just crawled. There's actually a lot of different types of content. There's text, CSS, plain HTML, text CSV, JavaScript, application XML, application JSON. There's all kinds of different encoding types or content types to consider what you want to do. So that's the first thing you're going to figure out what you're going to do. If you're from an SEO's perspective, maybe you just want to crawl. You want to just skip CSS and JavaScript for now and just crawl the content, right? So that might be one of the limiting factors that you want to work on just to start. It's better to take off a little piece and get that right before you expand your scope. How many bytes should you crawl, right? So the one thing you're going to find out is that you might crawl, 99% of the URLs that you care about, and then that 1% basically ends up hosing your program because it's this gigantic page or a PDF or whatever it happens to be. So you have to have a limit as to how much data you're actually going to crawl. So there's always a limit. Even Google has a limit. It just depends on fine tuning the storage requirements and all the things that are related to the number of bytes that you have to store. The other thing that you're going to need to consider is how many redirects do you want to follow. So one of the responses that you can get back from a web server is a redirect code, obviously, 301, 302. Any code in the 300s will indicate that the content you try to crawl is located at an alternative URL that you now need to fetch. And so there's other mechanisms that can trigger this as well. There's a meta refresh. There's location header fields. There should be, these all should be considered redirects, but you might want to just start out with 301, 302 redirects and progress to the more complicated things like meta refresh or location or any kind of weird things that are still considered redirects, and you have to program that logic into it. So obviously, we found that 3 redirects was sort of a nice happy medium. So in the market brew model that we built, it will stop after 3 redirects, and we actually will mark that URL as sort of too many redirects and mark it as an error code, essentially. Every search engine is going to be a little bit different. We always say, take it with a grain of salt what we're doing. We're building statistical search engine models. I don't have the code for Google. I have a lot of friends from Carnegie Mellon that I went to school with that are working at Google, but unfortunately, none of them have shared any of the code with me. So I'm not reverse engineering. I'm just taking it from a first principles perspective of this is how that modern search engine was most likely built. And so when I say things like 3 redirects is too many, well, that's what we found was sort of the sweet spot to make sure that we got rid of anything bad and didn't throw away anything that was still good. So that's sort of think about it that way. Is you don't want to you want to make sure that you pick a number and go with that. Otherwise, you end up with an infinite loop when you're crawling these sites. How long should you wait, right? So regardless of sort of determining the crawler should wait for web servers is a tricky thing, right? So and this is actually even more tricky now with the advent of all the JavaScript parsing. How long do you process this data? How long do you wait for the web server to respond? So these are things that setting the timeouts are very intricate because it depends on your own internal network. It depends on a lot of, it's sort of the chicken and egg problem, right? You must determine what the average response time is for the URL. And so you just essentially can start simple, like in the case of sort of like the size limit, and get more sophisticated in the future by storing average response times for specific URL or IP address ranges or by content type. It really just matters on how you want to set it up. But these are the things that you have to think about in the beginning when you start out is, sort of setting limits, what you need to do to sort of be able to get to the next level without being overwhelmed with all these things that you have to do writing a GoogleBot crawler.
So real quick, Scott. So are you saying like with redirects, are you saying like a redirect chain? So like 301s or a 302, 301, 301?
Yeah, exactly. So the redirect chains and typically, and there's so much with redirects nowadays, passing canonical, passing link flow, link juice. There's a lot of things that happen. But what we found is typically 3 redirects after that, it was not going to come back. It was going to be an infinite loop after 3 redirects the majority of the time. And so we set it to that specifically for the reasons that we found as we started crawling. So a lot of these things that you're going to find, you won't find until you actually start your program and start crawling these URLs and finding out what's happening. I'm just kind of giving you a flag as to, these are the things that are probably going to be coming across, and you should be aware or at least cognizant of these things as you start building and crawling to ensure that you have a very stable and successful project.
Yep.
the next thing you would want to do is have a mechanism to check your own crawler's networking status, right? Because you don't want to say all of a sudden one day, all the URLs are 404 because your network went down, right? That's silly. So you have to have your own checks, your own internal checks to make sure that you yourself aren't, let's say I'm saying that server farm or the computing cloud that you're working on, that isn't suffering any some sort of degradation networking wise. And if it does, you have to build in software that understands that your network is a little bit slower and adjusts certain things. So you'll have to adjust timeouts. You might have to relax those a little. You might have to have a lot of well, anyways, I'll get back into that in a second here, but that's essentially the sort of one of the libraries that you have to have in a search engine. You're going to find there's a lot of different libraries of software functionality that is going to be needed in different parts of the search engine. This is obviously one of the big ones for the crawler, is to have a sort of a network checker. The next thing that you want to think about is the character encoding, right? So when you're the internet has, I think it's 88 different active character encodings. You can check me on that. I think it's somewhere around 88. And maybe I would be somebody who would know that because we at Marker Brew, we crawl a lot of different languages, but there's different character encodings, and to parse those character encodings correctly, you have to determine the content that you're crawling. So there's a lot of libraries today. A lot of these things also, you'll say, hey, Scott, well, this isn't complicated. You can just download this library and this will do it for you. Well, 15 years ago when we were first building it, a lot of these things were not available, right? So we didn't have a lot of the modern libraries that a lot of the software programs have. And so some of this stuff may or may not be available. You may have to code this up yourself, but the character encoding is just, one of the first things that we had. One of the major problems with character encodings, and I apologize if it's too technical, but this is what you have to deal with when you're building search engines, is so we were using the Postgres relational database. Postgres is one of many different database choices, and that database at the time had a bug dealing with the null entity character. It's a /0 from a entity character perspective, but these edge cases essentially would crop up and essentially ruin the crawl that you're trying to crawl. And so things that determine things that cause bugs in other components or other parts of your infrastructure, you, as a software person, you have the ability to actually fix that through software. A lot of times when in other industries, if something breaks, you got to go get some material thing and need to fix it. With software, you can actually sort of, I don't know, you want to call it a hack, but you can hack around the other parts of the infrastructure that aren't quite up to speed yet. And of course, Postgres, they went from version, I don't know what we started with, 6 or something, and now we're up to 11 or 12, or I don't know. It keeps changing, but so a lot of things have modernized. But that's one of the things that would crop up as these weird bugs in other parts of the infrastructure that you then have to make sure you took care of with the crawler.
Well, and I'm sure from like a Google perspective too, like you're I don't know how many sites there are, millions and millions of sites, right? And then you have these problems crop up, and then all of a sudden now you're losing computing power basically to be able to crawl the entire internet efficiently. And so now you've got this problem that's stacking on top of each other, and I'm sure it gets out of hand rather quickly, depending on how much data you're actually trying to drag down.
Yeah, and then it's typically the hardest part to solve as a programmer is the performance bugs, right? So, but they do pay off, like you just said. Like it's money, right? The more processing power you need to buy, the less margin that you're going to make. So the goal is, as a software engineer, isn't to design one program, one piece of code that's faster than another piece of code. It's to design something that, when put on a million servers, works very efficiently together, and it marches forward as sort of a large army. And you do that as efficiently as possible, all the way down to the individual, single server, and making that as efficient as possible. and then expanding that as you go. We've always been very big on soft launches, so we will typically roll out features where we only expose those new features to a subset of clients or a subset of our servers, and we just let that sit on the servers for like a month. And if we like what we see, we don't see too many errors or anything like that, then we'll go ahead and push that to the rest of the server farm.
Well, if I may interject, a real interesting point to that was the May 4th or 5th update that Google did, and everything crashed down pretty hard for people. And then all of a sudden, like a month later, you see something creep back up as they're tweaking things. So it's kind of like along the same lines, right?
Yeah, that's really, and I've got a lot of friends at Google, so I'm not making anything, any bad comments here, but that's really just discipline from the software team. And that can also be pushed and broken by management, right? Management could say, hey, we've got some site here that's we can't have this on our search engine. You need to write some code to filter this out. And so they go and do it, and they have a 2-week timeline. They push it out, and all of a sudden they break. You have what you just described. So, and it's not an easy task. I don't envy the guys at Google doing this, but that's the type of thing you're going to run into when you deal with performance issues and stuff like that. So that's one of the things that you have to think about, and it's just one of a list of things, but that was one of the things that cropped up for us. One of the things that you want to think about is just crawling smartly, right? So you want to crawl as efficient and as smart as possible, like we just talked about. You'll undoubtedly come across tons of inefficiencies, which you will make the most efficient part of your system that will enable you to speed up the overall crawling experience. But storing certain metadata or meta information about your crawls can end up leading to a faster and leaner crawler. And that's what you want, right? You want a very fast and lean crawler. And it also has to take into the context of, where is it storing that data and stuff like that. Does it index along the way, or is it indexing it later before it stores into the database? There's all kinds of different things that that you have to think about when you're designing that. But essentially, one of the first things about sort of an example of how you would crawl smartly is sort of the preferred subdomain of a website, right? So most websites use the standard www subdomain, but not all do, right? Some leave the www part off, even when crawling the links on the content it serves says otherwise. So you instead of having to continually redirect the crawler each time it attempts to crawl a new URL, a smarter crawler would instead realize that this is unnecessary, right? So there's a lot of things that the crawler can learn along the way that you would manually do. We'd have our team of software engineers manually change. But if we start to see this as a pattern, we will actually code in that logic into the crawler so that it doesn't do that. Another more modern example is the HTTP versus HTTPS protocol. Most sites are now switching to the secure protocol of HTTPS, but they have not yet updated all of their links, right? So once you get past the redirect issues, you're gonna run into, it includes files like CSS and JavaScript. The crawler's gonna need to fetch all the resources of each page to correctly parse the content. And because they share CSS and JavaScript files, you don't need to do that every single time, right? So you can make a judgment call in your software logic that determines the length of caching and when it triggers the crawler to go back and recrawl those resources. That's very important, right? So if you have a site, like Walmart or Depot or something like that, you have tens of millions of pages. You don't want to be crawling a shared common resource 10 million times. So that's one of the examples of sort of what's thinking about crawling smartly, making your once you start out with sort of like the first layer of crawling, and it's kind of a dumb crawler, you're just doing crawling and nothing else. Then you can start adding on this additional logic layer on top of it and saying, hey, well, we've already seen this or whatever, and just making it. The goal obviously is to make it as lean and as fast as possible. Obviously the internet changes really, really fast. You guys don't need to be told that, but in fact, one of the biggest challenges in building a crawler today isn't storage or processing power. Back in the day, it was. We would have these. Let me see if I have a picture of this. Back in the day, we'd have these. There's me, by the way. That's my first computer when I was 6 years old. I don't know if you can see this. You can see this, right?
Yeah, it's showing. I had an 8088, by the way. That was my first one.
Very nice.
Aquarius.
Yeah.
Made by Mattel of all.
Yeah, so there's my wife opening up Dell boxes as we flood our house full of computers. So this is one example. Let's see if I can get a picture of. We'll see if I don't have it in here. Anyways, so that's essentially what the challenges were back 15 years ago. Is a lot of processing and storage power. Today, it's really the problem now. By the time you crawl all the pages in a website, more than likely a lot of those pages have already changed. And so expand that thought to the entire internet, and you've got a very hefty challenge. So many non-programmers, I do realize that I'm talking to probably more SEO people than software people. So when you think of how do I write a fast program, a lot of non-programmers think serially, right? So that is, they think to build the fastest crawler means you have to have the fastest computer. It has to be running on the fastest programming language. This couldn't be further from the truth. So one of the most important problems to solve when building a crawler is actually design it in a way that allows easy scalability. This used to mean hardware architecture, but today, in modern times, you can spin up an AWS server automatically. So we in fact, Market Brew, our commercial product, when it needs more processing power, we literally have it automatically knows this and then spins up additional servers to accommodate the extra traffic. So today, when you talk about fast, you're talking about scalability. So this what we did, and there's might be different ways to do this, obviously, but what we did is we actually broke the internet into shards. SHARDS, shards. It's a sort of a technical software term where we're sort of a logical group of data that can be physically put on separate machines, right? You can think about how you would partition that logical group. In the beginning, when we had clients, we would build their own mini internets, essentially, and they would all be on their own separate systems. So we have sort of a hub and spoke design where we have a catalog server that controls everything. It has sort of a knowledge about everything that's happening, whether that's throughout all the crawling process and the scoring process, the indexing, the query interface. It maintains all of that across all the different what we call server farms. And then we have individual server farms that break the internet up into essentially logical groupings or shards, where we are essentially delineating the lines of each server. There's different ways to do this. Google has done a slightly different approach. You can do it even in a different approach than that. It doesn't really matter. The goal really is just to use the modern cloud computing to scale up and as your speed increases in performance, it really is dependent on that scaling, right? Because you can take the fastest programming language in the world and the fastest computer in the world, and I can put, some code in BASIC running on, a Commodore 64. But if I give you 1 million of those, it will probably, well, maybe not.
Let's not get carried away there.
Someone do the math on that, but you know what I'm saying.
Seriously.
It's about the scalability. So you don't necessarily have to worry about what the programming language is or what how fast the individual servers that you're running it on. You just need to be able to logically break it up and have them all march forward as one army. So does your crawler have to crawl everything? The answer to this is probably no. Unless you're trying to create the next Google, it's likely that you only need to crawl a subset of the internet, right? And so this will be different for everybody. Everybody's going to have their own personal goals of what they're trying to get out of this. It might be as simple as scraping somebody's phone numbers off of sites, or it might be, I want to know
email addresses.
Email addresses, exactly. Whatever you want to do, you can program your crawler to go get that data, and if you design the scalability component into it, it becomes very powerful. You can unleash it on any part of the internet or the whole internet if you want to, and the scalability sort of takes control of the speed. So, at Market Brew, our commercial product, we mostly deal with creating models of specific parts of the internet. So we only need to crawl a statistical sampling of those pages at that given time. So accordingly, we created an intelligent crawler that learned how many and which pages it needed to crawl to build a statistically significant sample of the internet. So our goal was to build a statistical model, and we wanted to have a judge that we programmed essentially that said, yes, this is close enough to the real thing, or what's the distance between what we see on our model versus what Google is or Bing or whatever search engine that we want to compare it to. So it'll be different for each business model, but for an example would be crawling a subset and then on the next pass determining if a slightly larger sample gained any additional accuracy, right? So we can crawl a 10 million page site in 2 hours. And the reason why we can do that is because we can crawl a small sample and see if that model is actually reflective of reality. And if it's not, we can actually, it's sort of a feedback loop where we can expand the scope of that statistical model until we have the amount of pages that we need to essentially get the data that we need in decision making.
So here's a question for you. So how would that work? Like, so let's say I have a travel site, right? So like, how does your modeling deal with different verticals, like a travel vertical, a payday loan vertical, something like that?
I did that.
What's that, Jim?
We built a search engine in Hadoop specifically for financial sites. So
Yes.
Kind of what he's talking about. I'm curious how you did it. We did it based on seed phrases, where we'd look to see, like, does this particular phrase at least exist somewhere within the first on our initial crawl before we do any sort of deep crawls. But you probably have a very different model.
No, and you're going to find that, like, when you're talking about crawling or search engines, each one's going to be different because they have a different purpose, unless you're trying to compete with Google. So if you're DuckDuckGo and you're talking to Union Square Ventures and you need to come up with a Google killer or something, I don't know, but that's the concept. So the question is, how does it change? What part are you asking? What changes for each vertical?
So he wanted to know how you verticalize it. How do you determine whether it sites within a vertical?
Yeah.
So like let's just say that like you have clients, right? Each one of your clients is in a different vertical.
Yes.
And so you want to do something for one of your clients that's in a travel vertical. Well, if you're not grabbing enough of statistical data from that type of vertical, maybe it's treated differently than other verticals that are out there. So then how do you align for that, right?
That's a great question. So we'll talk about this in probably a later lunch and learn, hopefully. But I will do a quick preview. So the way that we approached it is, and this didn't start out this way. We started out as a rules-based engine. We tried to basically code up all the algorithms that we thought Google was doing back in like 2006, right? And when we got to about 2012, 2013, and Google actually started moving towards an AI approach where they took the same rules-based algorithms, but they put a sort of a placeholder of how important those algorithms were. And then they let the quality search rater guidelines, the humans, determine what good and bad websites were, and they fed that back into their neural network, and they filled in those dynamic placeholders on each family of algorithm. And so that's what we did at Market Brew. We actually said, hey, we don't know what the dynamic placeholders will be, and the importance of each part of the search engine model and the scoring engine. But what we can do is we can try to find a combination that looks and behaves the same way. So in doing that, each industry or each vertical is essentially calibrating itself to that set of rules that Google has internally. So we sort of have, and this was an invention that we had to create, right? So we have patents on this. So this didn't exist. We actually had to create we had to take our generic search engine model that we had created at that moment and combine it with a thing called particle swarm optimization. This is a artificial intelligence genetic algorithm that essentially can determine sort of the local maximum between two different settings. So basically, I wrote an article on this actually on Search Engine Journal 3 or 4 years ago. It goes into great detail about what particle swarm optimization is, but it basically takes the generic search engine and turns it into a live version of whatever search engine that you want to point it at. So you can type in whatever keyword, and it will literally turn into a search engine with all the algorithms set correctly with the right settings and weightings. We call them biases, but those settings will be automatically filled in. So we kind of cheat around that question because we kind of just, it's not like we code in a specific thing. If it's the travel industry, do this. If it's the ticket industry, do this. We essentially just built one generic search engine, and then we stripped away all the settings that we thought we knew. Back in the day, we thought we knew exactly what Google was doing. We just stripped those away and made those placeholders. And then whenever anyone of our clients use our search engine models today, they just basically automatically calibrate that generic model to whatever version or whatever part of the internet that they really care about. So that's our way around it. That's how we solve that.
Okay, that makes sense.
Yeah. So basically, what the next topic that I'm going to talk about is a very interesting topic that you will find out if you do unleash a large crawler on the internet, and that is crawling politely, right? Back in the day, well, 15 years ago when we were crawling, we would get emails, phone calls from people, just random website owners just saying like, what are you doing? You're encroaching on my privacy. And, we took a couple of those calls before we just stopped answering those calls. But what we did is we actually ended up we created our own, before privacy policies were required, we had a full, why is the market brew bot crawling your site? And so there's a lot of things that you need to figure out, but the most complicated part of it is building the robots.txt parser, right? So this might seem like a very trivial process, but it is not, I assure you. There are even modern libraries that will help you with this process, but it still needs a lot of tweaking. And that is to crawl the robots.txt file and understand what your crawler should be doing. Should it be throttling? Should it be slowed down as to not place any undue strain on the respective web server? We can actually probe web servers and determine how quickly or how slowly you need to crawl before you get banned, essentially, from their temporarily banned as a crawler. So, and that we extend that to, obviously our software. So we put in a setting for our clients so they can actually adjust the throttle settings and stuff like that for their own if they know more information about it than we do. But that's basically the next thing you really think about when you're building a crawler is that robots parser. And I may be biased, but I'm in the camp that believes that each and every public page on the internet should be able to be retrieved in a manner that abides by the robot.txt protocol and also not place any undue strain on the web server. You want to be good neighbors. And so some of the web servers will selectively decide who can access their public content. This is very common in 2020. And I can understand this, right? So many travel sites, for instance, will block attempted scrapers. Travel sites are very big on that. Any ticketing sites, because you have a lot of competitors that are trying to essentially just scrape their data and put up their business model on a different domain. And obviously that's
no, we would never do that. What are you talking about? That's crazy talk.
Yeah. So the scrapers are crawlers whose business interests are to copy and republish content, and that's a different story. So these crawlers will often use a proxy network, right? So everybody in the SEO space that has done any scraping or crawling knows about proxy networks, and essentially all that is it's just different IP addresses that you can crawl from, so as to sort of slow down or throttle the amount of requests that you're making from one specific IP address. And so these crawlers will use these proxy networks, effectively, trying to eliminate or not display certain things like user agents. So a lot of the credit to the enterprise SEO teams at a lot of these big firms, and I've talked to many of them, obviously, they're getting smart about how to deal with this. And so they have all kinds of different rules things that can detect what you're doing with Chrome. If it's a headless version of Chrome, headless essentially is without the browser screen. So what Market Brew did to bring its JavaScript compiling up to modern times is about 5 years ago, we implemented the Chrome browser into our search engine crawler. So what that means is once we crawl the data, we actually run that data through the JavaScript compiler that is run inside of Chrome. And that's called a headless Chrome version. Essentially, it's a Chrome that's sitting inside of a Linux machine that's just running JavaScript constantly. And this will kind of bleed into some of the other talks that we'll talk about, part of this search engine. And also Google has a representative that's actively talking a lot about JavaScript parsing. So probably just listen to him about that. But we effectively are paralleling that by doing the Chrome, headless Chrome. And so the headless Chrome gives us the ability to understand a little bit more about what's happening with the server, but at the same time, the enterprise SEO teams are getting very savvy about how to eliminate anybody that's not just a normal user. And so part of the problem you have when you're going to be building a crawler is you're going to run into a lot of sites that are way ahead of you in terms of how far they've developed their software and their processes. You're going to be just crawling and not having to not even thinking about a lot of these sites trying to block you, when in fact that's one of the things you will have to deal with right from the get-go. Otherwise, you'll have a very incomplete version of the internet, especially today. It wasn't so much like that even 3 years ago, but today it is, and that's good, I think, because what that's saying is there's a lot of technical prowess entering into these brands and these enterprise SEO teams. That's really what we want to see. We want to see, we've got Google on one side, who's got all the software engineers in the world, the best software engineers in the world, and on the right hand side, you've got the SEO space who wasn't born from software. It was more of a marketing origins, and a lot of software guys have come into that space. And so hopefully we eventually will get a little bit more closer to the technical level of what Google's trying to do. And that's sort of what Market Brew is trying to do. That's why we created Market Brew. But that's essentially what these talks are trying to do, is try to level the playing field. So you guys understand from a real search engineer what's actually happening. And I think obviously the most learning will come when you guys ask questions, specific questions about your specific problems that you're dealing with. So anyway, so that's sort of the quick talk about some of the things that I wish I would have known when I was building a search engine. I mentioned the Pareto principle. 80% of the problems will come from 20% of the URLs. I think it's actually even more skewed. I think it's like 95% of the problems will come from 5% of the URLs. What's interesting is it took us 8 years at Market Brew to get a stable crawler that could crawl the entire internet and keep doing it, basically. We would always run into edge cases. There'd be like one site out of like 10 million that we crawled that would cause the problem. And that's just going through and finding all the individual edge cases and that you will eventually run into as you're building it. So the next thing that we'll do is we'll basically, the next talk, we'll get into how we store the crawls and index the data. That's as interesting as talking about just the crawling, because the indexing is there's a lot of technical part of it, but it's also very important how you index the data, because in the end, your query layer, when somebody comes to your search engine, or if it's just an internal search engine, if you're using the search engine, that query layer, when you type in a search, it has to be instant. There can't be anything where it's trying to go and do like a query against a database where it's more than 10 milliseconds. And all of it's got to be prepared and ready to go. All the scoring layer has to be already done. So there's a lot of things that are very interesting when we get into the indexing part. But So anyways, that's the quick and dirty of the things that I wish I would have learned when I built a crawler. There's a million other things that we could talk about, but open for questions.
Well, I know I have one. One of the things that people always question, especially as SEOs, as an example, is, I have a JavaScript website. What does Google really understand about my site? Is it coded correctly? Is it not coded correctly? How do I know if it's coded correctly? I know that Bartosz created a what is it? What would Jesus do? It's what would JavaScript do? And that answers, I think, on a very basic level. Like, yeah, there's tags that are on the HTML side, or there's tags that are on the JavaScript side, but does Google really understand the page? And Joe and I had a client where the JavaScript was a freaking complete
atrocious.
Yeah, it was like the worst. So, what would be really interesting is to have a tool that can actually parse the JavaScript like Google would, show you in a graphical representation, like, hey, this is what we're actually seeing, and it is coded wrong, or yeah, it's great, like you coded it correctly. So very interesting.
Yeah, it's used by a lot of our clients, like Marker Brew. So what Marker Brew does, because we have the compiler in the headless Chrome, we store two versions, right? So we store the version that we crawled, sort of the uncompiled JavaScript version, right? What everybody else sees in the world, right? So if you load up a site and control U it on Chrome, and you're going to see the content. That's what people see when they load the page. But really, what's happening is Google is going to take that data, that DOM of HTML, and all the JavaScript references and CSS references and all that stuff, and it's going to run it through Chrome. It's going to run it through their headless Chrome, their JavaScript parsing engine that's part of Chrome. And then after that process is over, it will produce a new DOM, right? It'll have the HTML like it was showed before, but there might be additional nodes in that HTML. There might be more content, less content. It could be anything, right? You can have JavaScript rewrite the entire page. So the exit of that process, we do another snapshot. And that is what we actually use inside of Marker Brew in our model. But we can give the clients here's what you see and here's what Google sees, essentially. And that's really just using the headless Chrome. So if you're interested in that, definitely look into headless Chrome. There's a couple of really exciting libraries for a lot of different languages. So it depends on whatever programming language you're going to use. But the headless Chrome is a big one, and that will give you the JavaScript compiling that you need. I will warn you that the libraries, even out today, that some of them are 2 or 3 or 4 years old or more. There still will be a lot of tweaking to do, and that's because JavaScript, when it comes to parsing JavaScript, it's just all CPU, right? So it's pushing as much data as it possibly can, and when it does that, when you get into a situation like that, is you're trying to debug performance issues. If you say that, you might literally wake up a bunch of developers from sleeping right now, because that is one of the hardest things to do as a software developer is to debug a performance issue. So we spent over a year on integrating the JavaScript compiler, and that was just simply making sure that our servers didn't get basically hosed every time it tried to go into one specific edge case when it's parsing JavaScript. So again, that goes back to what we talked about earlier, which is first you have to set limits, right? What do you want your JavaScript compiler to do? How far do you want it to go? How much do you want it? How long do you want it to wait? In fact, that's actually a signal in one of our search engine models where how long that JavaScript DOM parsing works. And if it takes too long, we actually can measure how long and how quickly the screen is painted. There's different ways of saying it, but that's essentially really to understand the mechanics behind what Google is going to look at. Google's not going to wait around for an hour to parse your content. Our Marker Brew's search engine model limit, I think, is 60 seconds. So it's gone in 60 seconds if you're if you're not able to run that JavaScript in 60 seconds, we just toss it out. We use the non-JavaScript version of your site. And I would imagine that Google does the same thing. It's better than not using the site at all, right? So it has to default back to the non-JavaScript version. So if you were into like Black Hat today, right, which I don't recommend, we created Market Brew to show people how Black Hat does it with Google.
We got to boot Joe.
But what I would say is, if you do want to do Black Hat, and I apologize, Google, please don't ban me for giving out this information. But one of the things that you could do is make your JavaScript compiling, and this is if they don't just wholesale demote you for doing this. But if you cause the JavaScript compiler to go longer than it was waiting for, it would just ignore that, right? And you might say that there might be some advantages to doing that. Maybe you have certain things that you want Google to end up parsing and other things not. So it basically, there's a timeout for the JavaScript compiler, and I'm sure the Google guys won't get it heavily into this because of obviously the loophole you can take advantage of there. But what I suspected they did to offset this is they probably added some sort of penalty reducer to any site that won't run the JavaScript compilation. It's hard to tell. They don't have the code, but that's what we do. We basically time out after 60 seconds. We roll it back to what we crawled before the parsing, and that's what ends up in the model.
Yeah, if you have the ability to inject into a page that you do not own, you could definitely basically take it out.
You could do some damage. Yeah.
Yeah.
So William Sears is apparently on. So he has a question. Has anyone made a tool that takes all of the visible chunks of text on a page and then queries Google to see if that text chunk was found in Google's index? Good question.
Yes.
Good question.
Yeah, I mean it's not live anymore, but that was when we had something we called empirical rank, which is for empirical marketing. That was one of the major pieces of the variable. So we take random snippets like 140 characters, 280 characters, see like does that rank for the phrase? If so, we view that as a quality signal. I'm sure there's probably a Python library that does exactly what he's talking about. I don't know off the top of my head, but
yeah, this is actually a trivial thing inside of our Market Brew search engine model, and that's only because it's been built up with millions of different libraries. But it's trivial today because we have the ability to do it. So we can take and search across any site, or we can even do a grouping of sites. But yeah, you can do that, and that's a really awesome idea, William. It's something that I love the ideas that come out of just thinking about from the software perspective of things, and this is sort of what ends up happening is we come up with really cool ideas to do that. So, yeah, we don't have a public. Our interface is really kind of more of a Swiss Army knife. It's not a one individual set of tools, but that way Google indexed that text. He says.
Yeah,
exactly, correct.
Yeah. So here's a question for you too, Scott. So, obviously there was a big core update in May, and people are still kind of scrambling to try to figure out what happened. So like, how does Market Brew deal with such a dynamic change in Google, where now you have to kind of figure out what it was that they were trying to kill or alter, right?
Yeah. So this is one of the things we do really well, right? So I would say, one of the things that is unique about Market Brew is that we can take the model before and after the algorithm change. The models are stored with all the different weights and biases on all the different families of algorithms in our search engine model. And as the algorithm update occurs, the model diverges from reality, right? So the model was in sync. Everything you see in Market Brew's model was doing exactly what was happening on Google, and now Google has diverged. And so the process that we go through is that particle swarm optimization that we do now on the setup of any search engine model. We take our generic search engine, we find the bias and weight settings of all the different families of algorithms to make it behave like the real thing. We do that same thing when algorithm change occurs, and then we can look at the bias and weight settings on all the different parts of the model before and after. So for instance, if you want to know if there's more importance on like the meta title today versus before the algorithm shift, you could know that. You could see if it's gone up in importance, it's more heavily weighted or less heavily weighted, and how much compared to all the other parts of the search engine. So yeah.
Wouldn't it behoove you then, as as seeing what you can see to basically put out like, hey, this is what changed?
Yeah, we're actually doing that. We're in the process of working. We're still looking for content providers to want to team up with us to basically take our conversation reports. We call them conversations. Essentially, you can put in any keyword you want into the Market Brew system, and within a few hours, it will build a statistical model and show you exactly why things are separated the way they are in the model. So it'll show you all the way down into individual algorithms, who's the outperformer in each part of the search engine. So that's essentially what we're doing, is we're being able to determine the behavior and characteristics of the search engine. I call it the machine learning machine learner.
It's the Wonkavator.
The Wonkavator. That's
well, from my perspective, obviously being an SEO, like there's so many people that are still asking questions about what happened with that update, right? And I have a customer right now that I'm dealing with, and I'm looking into seeing like what happened. Like their traffic loss was about 50%. And it wasn't just mobile or desktop, it was everything. And then, I've noticed that they got some AMP pages that aren't being used consistently across the site. So, for me, it's like it's like a game of Battleship, right? Like, how do I figure this out? And, I know the DMO would love to be the content host for everything that you have about this, because there's so many digital marketers that we have that obviously need to know this information as quickly as possible. And if we can, disseminate that to them, I know that it'll save time, it'll save effort, and hopefully save some customers for these folks too. Instead of just going month after month after month trying different things, like that sucks not knowing. So
here's the thing. So I would love to help the industry as a whole. Obviously, we can get some recognition out of that, but I would love to put that technology out there in the hands of people to write about what's going on. The only caveat is that you have to have a search engine model set up before the algorithm change occurs, right? Because then you don't have anything to look back at what the model was doing before. So we do have we had an initiative earlier this year where we started tracking a lot of major keywords, just to track them, just to have them in case there's a specific keyword that came up. We can go back, and we've already had a model set up so we can see the settings, the bias and weight settings on all the different algorithms, and then compare them to the one that just happened and come up with a game plan for that. And our clients can do that as well. But essentially, I've considered, and obviously this is a bandwidth thing on our side, but we would love to find a content producer to be able to take our reports and just give them access to Market Brew and just say, hey, whatever keyword you want, write an article on that, and you can go to town. You can use any of the data with Market Brew you want, and things like a big algorithm shift, and you want to determine what might have happened. That would be another tool in the arsenal of all of us to understand what's going on.
I think I would be totally interested. What about you, Joe? Seems like a pretty good investment in time and effort.
Yeah, definitely.
So
awesome.
We'll talk offline, and maybe we can come up with some cool ideas for everybody. And so the next thing we would like to talk about is, obviously we'll go up one level up into the indexing and storing of a crawler, and we'll finally finish with essentially a full built search engine of how the process of building that entire stack came about, and then also all the things that we can talk about, what you can do with it, right? Which is what we just talked about. So one of the ways that we can characterize a Google algorithm shift is we can use these models to actually characterize what's happening from an actual data perspective, not just something like, hey, it looks like this site was affected and this site wasn't affected. That's the old way we used to do it. Now we just basically let the search engine model and that particle storm optimization, where we take the standard model and transform it into a sort of a version of that search engine. We use that technology now to answer those types of questions. So there'll be some cool things we can talk about. We can go on for hours, but this is.
I know. We will. We will. All right. Well, I wanted to say thank you again for coming today. We obviously appreciate the knowledge, and I'm sure that everyone who's watching and will watch this video will definitely learn some. Scott, why don't you go ahead and plug Market Brew? I mean, we've kind of done it enough, but let's do it one more time and make sure that we can get some people over your way. And sure. It was great. I really appreciate you coming today.
Yeah, I really appreciate it. And there's two sites. So the one site, this is not a commercial site, the Ask a Search Engineer. So if I put that in, let's see. So this is just a site that I've actually talked to a number of other software guys in the industry right now. Some potentially you could call competitors of mine, but just other software search engineers who have developed parts of a search engine or maybe a whole search engine to start contributing on this site, Ask the Search Engineer, just as a way to kind of level up the playing field, right? All you guys out there in the SEO industry, you have no real access into what actually is happening inside of Google. You just have a bunch of paid PR people to tell you exactly what they want you to hear. And you guys already know that, obviously. This has been going on for a long time, but this is the site that's sort of giving this the ability to just try to level that playing field. And then if you're really interested in Market Brew, I can talk a little bit about that. Basically, this is a commercial version of the concepts that we're talking about, and we take clients on that are looking to understand how Google or whatever search engine they're looking at is consuming their data and also scoring all of it. So we built this system that allows you to take this generic search engine that we've built and point it at any keyword that you want, any search engine you want, any language that you want, and it will transform this search engine into that version of the search engine. And so we can produce all kinds of cool stuff. There's a thing called Market Brew Conversations, which, let me see if we can pop that in here. These are the reports that we essentially are producing automated. So here's one for weight loss. And you can kind of see what Market Brew is. It's essentially cloning whatever search engine we want to, and then we can open up that search engine and you can actually dive into and understand things like the specific different algorithm scores for individual sites, your site versus your competitors or the outperformers in that part of the search engine, the query parser and its scoring methodologies. All of this is sort of wrapped up into this, and you can kind of see exactly what's happening with the sites in this model. So there's 3 sites in this specific model. You can see the current model rankings versus the previous model rankings, and then you can start to see different things like CDC.gov has increased its rankings from March 7th to March 19th. This was run on the 19th. So you can kind of start
wonder why.
Yeah, so just total coincidence there. But yeah, so you can realize that all the way down into individual parts of the model. So you can actually see, what the outperformer is in the meta title, right? Or the outperformer is in the content, or the link backlink structure. Who has the best backlink structure in that set of sites? And what it's doing here is it's actually breaking down all the different components of the final query score that takes the order, that determines the order of a search result when somebody types in a keyword. And it breaks all that down into individual parts of the search engine model, so you can compare your site against the outperformer, probably your competitor, and see why they're doing so well in this part of the model. So that's essentially what the quick and skinny is for Market Brew. If you want to visit marketbrew.ai or marketbrew.com and get a demo, you can obviously do that right there. So
awesome. Well, thanks, Scott. Again, I appreciate it. And to everyone who's watching, please click like and subscribe and the notification bell on the video, and you'll get more great content like this. We're trying to do these weekly, or sometimes even 2 or 3 times a week as we can. So really appreciate Scott for coming again, and all of you for watching. So thanks, everybody, and we will see you on the next Nourishing Greatness. Thanks.
Thanks, guys.
Bye.